All right, so I wanted to redo the common assessment videos because your teacher made some glaring mathematical errors. It happens, it was late at night when I solved this up. So, number one, it says the larger of two numbers is four more than the smaller number. And if the sum of these numbers is 74, we want to find those numbers. Okay, so let's talk about what this means. I'm saying we have a small number plus a large number, and adding those together will give us 74. Okay. Now, if I so I'm going to let the smaller number be equal to x. Okay. We're going to use that as the x variable. Okay. Then I'm going to let the larger number, okay, it says the larger the number is four more. So four more is plus. So four plus the smaller number. The smaller number we said is x. So that's going to be 4 plus x. So in place, I'm going to substitute in for the word small. I'm going to substitute in x. And then in the place of large is going to be 4 plus x. And then that's going to be equal to 74. So now, as you can see, we have an equation here. So I'm going to go ahead and solve for x. I'm going to combine like terms. So x plus x is going to give me 2x. I'm going to add 4 here, and that's going to give me 74. I'm then going to subtract the 4 from both sides. So that's going to give me 2x is equal to 70. Divide by 2, divide by 2. That's going to give me x is equal to 70 divided by 2. 70 divided by 2 is going to give me 35. Now, we said x is equal to the smaller number. So that's over here. The smaller number is equal to 35. But then we said the larger number is 4 plus the smaller number. So that's 35. So now we're going to add the 4 to the 35, which is going to give us 39. So our numbers are going to be 35 and 39. 35 being the smallest and 39 being the largest. Number two is where I made one of those mistakes. I had no excuse. I just made some basic calculation errors. We all do them. It happens. We're all human. Okay, so I want to find which equation has no solution. No solution means not true. Our answer is going to be false. So I want to go through it and look at each one of these and think about whether or not it's going to be true or false. Well, if I look at 9x plus 9, and then I combine these like terms there, 11x minus 2x, that's going to be equal to 9x. Continue the plus 9. These two equations are equivalent statements. That's true. They're the same equation. So that means we have infinite solutions. So this A is not our answer choice. I accidentally somehow made a calculation error and put that it had no solution, which that was wrong. Okay, letter B. So I'm going to distribute here again. So this is going to be 7x plus 30 is equal to, now I need to distribute that 6. So that's going to be x plus 6x, and then 6 times 5 is going to give me 30. Okay, I need to combine like terms. So this is going to become 7x plus 30 is equal to 7x plus 30. Again, same equation. So this is true. So we have infinite solutions. If our answer is true, if it's the same equation, it's going to be infinite solutions. Next one. I have negative 5x plus 9 is equal to 2x minus 7x is going to give me negative 5x. And then I have plus 9. Again, same equation, so that means that's true. And that means that we have infinite solutions. All right, I'm going to pause. All right, so we're going to continue where I left off. We stopped off at letter C. We found that our equation was true. So I'm going to continue with letter D and do the same thing. So we know that this is true. B is true. So B is not our answer choice. D is not our answer choice. Well, by process of elimination, it should be D, but let's just check. So this is going to be 7x minus 6, and that's going to be equal to, we need to distribute that x. So that becomes x plus 6x plus 30, because 3 times 5 is 30. This is then going to simplify and become 7 minus 6 is equal to 7x plus 30. These variables are going to eliminate each other. So minus x, minus 7x, minus 7x. That gives me negative 6 is equal to 30. That's not true. That's false. So that is no solution. Okay. Number 3. All right, if I look at question number 3, I'm going to do the same thing. I want to say how many problems and how many solutions each one of these questions have. So if I look at negative 4 times 2x, that becomes negative 8x. Okay, and then negative 4 times positive 1 is going to become negative 4. That's going to be equal to negative 8x minus 2. Now, if I add 8x to both sides, these variables are going to eliminate. So that's going to give me negative 4 is equal to negative 2. That's not true, so that means no solutions for our first question. Second question, all right, we're going to distribute. So that's going to be negative 5 minus 9x for our left expression. That's going to be equal to 3 times 1, which is 3. 3 times negative 3x, which is negative 9x. All right, combine like terms. Oh, I forgot my 8. Don't forget your negative 8. Ooh, very careful. Very, very, very careful. Watch that. Don't make that mistake. Combine like terms. So this is going to become negative 5 minus 9x is equal to negative 8 plus 3. Negative 8 plus 3 is going to give me negative 5 minus 9x. Okay? Now, as you can see, they are equivalent equations. Let's look at this. If I add 9x to both sides, that's going to cancel. That's going to give me negative 5 is equal to negative 5. If I were to add 5 to both sides, that would give me 0 is equal to 0. This is true. So that means I have infinite solutions. This is also the same thing as saying an identity. Okay. Let's see. Number 4. Let's go to question number 4. All right. Sarah May is solving this equation and we want to distribute. Her steps are given below. Okay, so if I distribute 3 times 2x, that gives me 6x. 3 times 2, so 3 times 2x. 3 times positive 2 is going to give me 6. Then she brought down the negative 3. So far, her steps are looking really good. 6 plus 3x, okay, that's correct. Now she combines like terms. So she has 6x minus 3x, which simplifies to 3x, brought down the 6. So that's correct. She brought down the 6 plus 3x. So far we're correct. Then it looks like she added 3x from both sides because it's eliminated in her next step. If the 3x is eliminated, which it is because we would subtract 3x from both sides, that would give you 6 is equal to 6. So that is correct. So that gives you, and if you subtract 6 from both sides, that would give you 0 is equal to 0. So her correct steps are correct. And she has infinite solutions. Now understand that if we were to solve an equation like this and we got 1 is equal to 2, that's not true, then she would have no solutions. So make sure that you're paying attention to that concept. Okay? Number 5. And number 5 is another one that is where I made a calculation error. The error I made, I'm going to rewrite the equation. So I have 2x divided by 3 plus 4 is equal to 3x divided by 5 minus 2. Okay, I'm going to get rid of my fraction, so that means I'm going to multiply by my common multiple of 3 times 5, which is 15. When I did the mistake that I made is when I distribute that 15, which needs to go to all the terms, I didn't do it to my negative 2. So this should become 3 into 15 is 5 times 2, which is going to give me 10x, plus 15 times 4. 15 times 4 is going to give me 60. Then 3 times 3 is going to give me 9x because 5 into 15 is 3. Let me write it over here just so you can see this. So I'm saying 5 times 2x divided by 3 plus 15 times 4 is equal to 15 times 3x over 5 minus 15 times negative, not negative, it's positive, so plus 15 times negative 2. There we go. Okay, so that would become 3. So 3 times 3 is going to give me, nope, 5. 5, that should be 5. 5 times 2 gives me the 10. 15 times 4 gives me 60. Then that becomes 3 here. So 3 times 3 gives me 9x. I'm going to bring over the 15 times negative 2 is going to give me negative 30. So now I'm going to subtract 9x from both sides. That gives me x plus 60 is equal to negative 30. Subtract 60 from both sides. Cancel. That becomes x is equal to 60 plus 30 is going to give me negative 90. Okay. So that was the mistake I made before. I'm going to go ahead and stop here and then continue it in the next video, the further questions, because again, I don't want it to get too long. See you then.